Now here's another very interesting problem. This is now a problem that involves multiple ideas that you are going to need in order to solve homework problems and quiz problems. A motorboat starts from rest and heads due east with a constant acceleration of magnitude 2.8 meters per second squared. After traveling for 140 meters, the motor is throttled down to slow the boat down to 1.2 meters per second squared until its speed is 16 meters per second. Just as the boat attains a speed of 16 meters per second, passes a buoy due east of the dock. What is the distance between the dock and the buoy? Okay, now this is going to involve a couple of different ideas, but it's going to be very simple, so hang in there, okay? So the first thing we are going to do is we are going to, as always, draw a picture. So now we have a boat, right? A boat, I'm just going to make it into a sailboat. It doesn't tell me what kind of boat it is. Oh, it actually does tell me. It's a motorboat. So I'm just going to make it into a sailboat. And it travels, it starts from rest, so that basically means V0 equals 0 meters per second. And it tells me that it heads due east, right? And its acceleration is 2.8 meters per second squared, right? And after traveling for 140 meters, so after delta x, which is 140 meters, the boat is now throttled down to 12, I'm going to call this A1, and A2 is 1.2 meters per second squared, right? Until its final speed, VF, is 16 meters per second, okay? And just as the boat attains a speed of 16, it passes a buoy due east of the dock. So it just passes something like that. So now the question is, what is the distance between the dock and when it attains the final speed VF? So our basic question is we have to find this distance, okay, which is made up of x1 and x2. Okay, and we have our equations of motions, handy dandy equations of motions in order to help us. Okay, so let's start with our problem. So our problem basically is that I have to find x net. Okay, x net equals what? And I know that my x net is a sum of x1 plus x2. x1 is 140 meters. I know that. Plus blank. That's what I'm looking for. Okay, now how do I find that? In order to find x2, I have all of this information that's going to help me. So for example, I know that if I use my equation number 3, I have 2a delta x equals VF squared minus V naught squared. Let's call it 2, right? So 2 and 2. Okay? I know that my acceleration is 1.2 meters per second. Delta x is what I'm looking for. Given that this is 16 squared, I run into trouble because I don't quite know what V20 is. Okay, so here's my problem. Okay, now how do I find that? Note very carefully, this final velocity right here, or this final velocity from this leg, has to be the initial velocity for this leg. So that means final velocity here is initial velocity here for the second leg. So V1F is the same as V20. So somehow I need to be able to find V1F. Now how do I find V1F? V1F I know will be equals to V20. Okay? What equation can I use to find V1F? So, coming back here, I have A, I have V0, I have delta X. So I can use 2A delta X equals Vf squared minus V0 squared for my first leg, right? What does that give me? That gives me 2.8 meters per second squared. Delta X was 140 meters. My initial velocity, it told me was at rest. So this means I can calculate V1F squared. I can do a little bit of an algebra, a little bit of math, plug numbers in, and I come up with a value for V1F, which is 28 meters per second. Okay? Which means I can plug this number, 28 meters per second, into here, right? So this question mark gets replaced with 28 squared. Now I have all of the things that I need except for delta X. I can do a little bit of plugging numbers into the calculator and I'll come up with delta M. Please go ahead, plug numbers in, come up with delta X. I get 220 meters, which I can plug into here. So this question mark goes away and I get a 220 meters over here. And so my X net, the one I was actually looking for, comes out to be 360 meters. If I've plugged in numbers correctly and you guys all agree with me, that is what the answer is going to be. So the total distance that the boat travels from here to here is 360 meters. Now the next part of this question asks, sketch a graph of Vx from the boat to the dock. Okay, so we now need to be able to figure out the graph with respect to t and v. If this is 10, 20, 30, how does this vary? So for the first leg, what was the velocity? Okay, so noting that I'm not going to worry too much about that graph, my first velocity was, at the end of it, 28, right here. So it goes something like this, 28, and then my next velocity is about, now where was that again? 16. It's going to come something like this. And that is going to be my graph of v as a function of time, from here to here.